Welcome back, everybody, to Section 3 about mixtures in Chapter 1.1, Composition of Matter from Purposeful Design, Physical Science. My name is Mrs. Pound. If you are one of my students, you should have your notes out and you should be following along, writing on your notes. Remember, the big space on the left is for 5 questions that you are going to write about the notes, questions that you think I might ask on the test, because that is the purpose of these notes. You will be tested on them. If you're not in my class, you're a homeschooler or a teacher watching this and perhaps even using these videos with your class, my notes are available for purchase on Teachers Paid Teachers. So let's get started talking about mixtures. Our objectives today are to identify different types of mixtures. There are 2 types we're going to talk about, and to describe methods of separation. We can separate mixtures. Unlike the pure substances we talked about in the last lesson, elements and compounds, which could not be separated, could not be broken down, we can separate mixtures. So let's get started on that. A mixture is a combination of 2 or more substances that are not chemically combined. Remember, compounds were chemically combined. There are 2 types of mixtures that we are going to study. There are heterogeneous mixtures. This is a combination of substances in which the particles are not uniformly distributed. And an example is the bird seed here. In the bird seed, we can actually see the different types of bird seed that make up this mixture. We could pick them out. So we can see them, we can pick them out. And so we know it is a heterogeneous mixture because of that. Some other examples of heterogeneous mixtures that you might know of are a salad. It's a mixture of vegetables, perhaps even some fruits in there. Salad dressing, because especially Italian dressing, we have to shake it to get it all mixed up because it will settle out. Another example is soil. Soil is made up of dead materials like from plants. It's also made up of sand and other particles that we can separate. Perhaps there's some rocks in it, and so we would be able to separate that. The other type of mixture we're going to take a look at are homogeneous mixtures. This is a combination of substances in which the properties and appearance are the same throughout. So if we take a look at the picture, here is a bottle of pop. Yes, I'm from Western New York, one of the few places that calls it pop. You probably call it soda, or if you're from the South, just everything's Coke, right? So here is an example in this soda of a homogeneous mixture. This is a mixture of things like sugar or corn syrup, flavoring, carbon dioxide, which is a gas, and it's all mixed together. We cannot see little particles in it like we could with the birdseed. So that is a homogeneous mixture. Now looking at the glass, I like this picture too because it actually has both types of mixtures. The pop itself, or soda, is a homogeneous mixture, but when we add lemon and ice cubes to the glass, we now have a heterogeneous mixture. Some other examples of homogeneous mixtures are the air around us, other drinks such as perhaps lemonade, okay, where we can't see the sugar and the water mixed in. So salt water is a homogeneous mixture. So I said that we can separate these. So some methods of separation that we use are first distillation. This is a method of separating a liquid mixture by heating it so the liquid evaporates and condenses. An example of this is salt water. So in this flask here, it's being heated up and it might contain salt water. We're just going to say it contains salt water. So when it heats up, the water evaporates and goes up in this tubing, and it is cooled. There's actually cold water running around this tubing here in the background. The water then vapor condenses and comes out the other end as liquid water. So that is an example of distillation. We won't get that fancy in class. We will be doing distillation, but we will just let the water evaporate into the air. So you have probably seen this process, just not this type of setup. Distillation is also used to separate the components of crude oil. When we manufacture oil, it separates it into, say, the motor oil, the gasoline that we use, and the different components that we use. It's also used to separate things like if we're making something like rubbing alcohol. So a common process that we use in chemistry. Also, we will be doing filtration, the use of paper or other materials to remove solid particles from a liquid mixture. If you made coffee using a coffee pot this morning, or a coffee maker, you probably used filtration. The coffee filters filter out the coffee from the water. And another example is sand and water that you can filter out. If you had a mixture of sand and water, you could use a filter. We use filtration for all kinds of things to separate solids from liquids. This is probably the process that you're most familiar with. The final method of separation we're going to talk about is chromatography. This is probably the one you're least familiar with. This is a method of separating mixtures according to how different components are absorbed. So an example is, you've probably seen this, but just did not know what to call it. Black ink bleeds and shows other colors. So maybe you were working on an art project and you were using a black marker and it got wet. When it got wet, you may have noticed that it spread out and separated into many different colors. Black ink is made up of different colors. It's just not black. And so you watched chromatography happening. You can do this process at home. Go ahead, take a black marker. The best thing to do this on is a coffee filter, and drop drops of water on that black marker and watch it spread out. If you don't have a washable black marker, maybe you have a Sharpie, you can do the same thing with a Sharpie, but you have to use rubbing alcohol, and you can watch this process of chromatography. So historically, how have we used separation historically? Historically, this process has been used by the 49ers when they were panning for gold. Miners took metal pans and washed the mixture of river sediments. The smooth metal pan had slightly angled sides, and as the miners swirled the water, maybe you've seen an old Western movie where they're just swirling that water in a pan back and forth, the lighter particles washed over the sides, leaving the heavier particles, including the gold pieces, in the bottom. They then used a magnet to remove iron-rich sand after the pieces dried, and the gold was picked out from what was left in the pan. So gold miners used this process of separating mixtures. So let's take a look at our objectives again. We said that we were going to identify different types of mixtures. We did that. We talked about homogeneous mixtures, which are the same throughout in appearance and properties. We also talked about heterogeneous mixtures that are not the same throughout, and that we can really kind of, in some cases, even physically pick those pieces out. We talked about different methods of separation, that we can use filtration for heterogeneous mixtures, that liquid mixtures, we can use distillation of homogeneous liquid mixtures, and we can also use chromatography for some of these homogeneous mixtures, like a marker. Now it also says, if you notice, I have one extra objective. In class, we're going to separate mixtures using these various methods. So if you are my student, you should have your notes finished. If you need to go back and rewatch anything because you didn't uh, understand it or you didn't catch something, go ahead and do that. Fill out your notes and remember your 5 questions in the margin.